2.2, more on functions and their graphs preparation. Determine whether each graph is an even function, an odd function, or a function that is neither even nor odd. So we're going to do more practice on this. This looks like this is an even function, right? Because it's symmetric with respect to the y-axis. So every point all along here, you're going to have a corresponding one all along here for the negative. The same negative x's are going to spit out the same y's. So whether the x be negative or positive, you're going to have the same y's, the same height. Over here, it's neither. And over here, we're going to have odd. So you can kind of imagine that any point over here, whatever that height is for that x, so like say this is x is, I don't know, 2, right? When you go to negative 2x, you're going to have the same negative y over here, and over here you're going to have the positive y, this is the same kind of thing, right? So that's how you can tell it's going to be odd. Identify even or odd functions from equations. Okay. So just like before, we showed graphically, algebraically, we're going to do exactly what we said previously. So if I want to know if it's an even function, I'm going to plug in a negative x. If it spits out the original function, right, whatever that original function is, then we know that that is going to be an even function. Okay, so whether I plug in a positive x or a negative x into the entire thing, the function after simplification is identical. Now, odd functions, if I plug in a negative x, it should spit out a negative y value, right? So it's the original function, but it's the negative version of that original function. That's what that's telling you. It's the negative version of that function. So basically, if you multiplied that function by -1, the entire function, every term in it, and it flipped all the values, okay? If you plug it in a negative x and you simplify and you get that function as if you had multiplied the entire original function by -1, then we know that that means that is going to be an odd function. I'm going to do some examples of this, so I know this is kind of abstract right now. And if it's neither even nor odd, then it's neither. Okay, there's no separate test for neither. It's just that if it fails the even test, it fails the odd test, then it's the neither. It's not going to be either. Okay, so let's do some concrete examples here. And there's a pattern you're going to learn later on that will make this a lot easier, but we're going to pretend like we don't know the pattern initially, and we'll see what we get. So let's plug in a negative x. So I say negative x cubed minus 6 times negative x. Okay, well, a negative cubed is going to be a negative. A negative times a negative times a negative is a negative. So this is going to be negative x to the third power. Over here we're saying negative 6 times negative x is going to be positive 6x. And we're going to say right there, okay? Now, notice that if I just took the first term of the original one was a positive x cubed, and now we have a negative x cubed. This sign has flipped. The next one, we had a negative or subtraction of 6x, and now we have the addition of 6x, right? So both terms, there are only two, their signs flipped. So we know this one must be odd. We plugged in a negative x, and it flipped the entire equation. All the signs of the entire original equation were flipped, so this is an odd one. Now notice that both of the terms within this, they're odd, they're odd exponents, right? So x cubed, 3, that's odd. X to the first power, that one's 1, right? So it's a 1, okay? So let's try the next one. We're going to reference that back, but we'll be able to do this with patterns in a bit. Okay, so let's plug in a negative x for this one. Negative x. Negative x, so we plug in a negative x. Negative x to the fourth power, minus 2. Negative x to the second power. Well, if I take a negative to a fourth power, I get a positive. And then to the fourth power, still to the fourth power. Okay, same kind of thing here. I take a negative to a second power, I get positive, and second power. Now notice that when I plugged in the negative x, I end up getting back the identical or original equation, right? All the signs are the same. Positive x to the fourth minus 2x squared, I got back the original. So this one must be even. This must be even. Now notice that that's a fourth power, and that's a second power. Both terms had even powers, and I ended up with an even equation. That's not an accident. All right, let's try the next one. So now we have x to the, h to the negative x. So wherever we see an x, we plug in negative x squared. Plus 2 times negative x plus 1. All right, so a negative to the second power is a positive. And then we're going to say a negative x is just going to be a negative x, and a 2 times negative x is negative 2x, and then we say plus 1. Now, we didn't get back the original equation because we had a positive 2x originally, and now we have a negative 2x. So it didn't pass the even one. Well, what about odd? Well, Odd means all of the terms have to have the opposite signs. Like if I flip everything, I multiply the original equation by a negative. Well, we have a positive x squared and a positive x squared, so that one didn't flip. And we have a positive one and we have a positive one, right? So that didn't flip. So we had one term that flipped, the other two stayed the same. So this doesn't pass the odd and it does not pass the even function test. So this is neither. So it's neither. Now notice that you have an even power term, an odd power term, and then we have a constant right here, okay? So it wasn't all one or the other. So that's not an accident, so that we got neither, right? So if we had all odd, or 1, then we're going to say, it ends up with an odd one. If it have all even, we're going to end up with an even. If we have even and odd, it's going to give us neither. Now, this is going to get a little more complicated later on, but so I don't want to overemphasize that pattern, but that pattern's real. Okay, so let's try the next one. Is there a relationship between the exponents in terms of the function's equation and whether or not the function is even, odd, or neither? Yes. Consider the functions where the equations all contain polynomials in x. So x cubed minus 6x is an odd function. Well, yeah, right? We had a 1 power and we had a 3 power. Okay, consider gx is equal to x to the 4th minus 2x squared is an even function. Yeah, because we had an even exponent and we had an even exponent. Every term contains x to an even power. Cool. And then, of course, we had the last one where neither an even function nor an odd function. We had it kind of mixed up. We had a second power, we had a first power, and then we had a constant, which is kind of like a 0th power. But regardless, it kind of danced around. It wasn't consistently even or odd exponent powers, so it's neither even nor odd, okay? Or an odd function. Okay. There's a combination of even and odd powers, so it's neither. A constant term has an understood even power of x to the 0th power. Thus, the function h of x is equal to x to the 5th plus 1 is a combination of odd and even powers. So you can actually kind of think of this term right here in terms of that would be 1 times x to the 0. Well, x to the 0 goes to 1. So that would give you 1 times 1, which would be 1. So whenever you see a constant, it's just kind of understood to be a 0 power. It's just something you might want to memorize right there, right? 0. And we consider that an even power.